The Arctic region around the North Pole is a place of unique features. Its population, its natural biodiversity, its waters and climate. This is what we learn at school in Norway. It is also a region of extremes, highly vulnerable to climate variations. Arctic landscapes and ecosystems reveal the hazardous impacts of industrial and human activities from around the globe. The troposphere, the lowest layer of the atmosphere, is where our weather system operates and surface temperature variations take place. It is where greenhouse gases drive the well-known phenomenon of climate change. The layer above it, the stratosphere, is also seeing change. That is where we find the ozone layer. The depletion of the ozone layer, a commonly known effect of human activity on the environment, has been putting humans and ecosystems at risk. In the 1980s, the discovery of the ozone hole down south over Antarctica by British and Japanese scientists triggered action from the international community to eliminate the chemical substances that destroy ozone.
It will have consequences, both on ecosystems and maybe also for humans.
Ozone layer protection and the changing climate are topical for the Arctic Council. Founded by the 8 countries that surround the North Pole, the Intergovernmental Forum keeps the region's environmental issues under careful surveillance. More than 20 additional non-Arctic countries and organizations participate as observers. Arctic ozone depletion is of global concern. A large depletion over the Arctic eventually spreads out, lowering ozone levels across the entire northern hemisphere. Along the 50th parallel, where lie cities such as London, Vancouver, and Mongolia's capital Ulaanbaatar, some of the strongest levels of UV radiation have been observed since the ozone layer has been monitored. Movements in the atmosphere such as airflows and winds are what we call atmospheric dynamics. Ozone is photochemically produced over the tropics and then transported by dynamics to higher latitudes, where it accumulates over the poles. Very cold temperatures allow the formation of polar stratospheric clouds, which can activate chlorine from man-made chemicals in the atmosphere. A powerful current of air, the polar vortex, confines the chlorine chemicals over the poles where they rapidly destroy ozone molecules. Part of the sun's radiation is absorbed by the Earth, which warms the surface. This causes the emission of long-wave radiation back into the atmosphere. The increase in greenhouse gases is trapping this radiation, warming the lower atmosphere. With less radiation making its way to upper levels, the stratosphere and layers above it are cooling,